ABSEMI, the Brazilian Association of Semiconductors Industry, brings together industries and government-owned and private technology, research and development institutes, covering all chains of semiconductors in the country. Established in 2014, its mission is to promote the dialogue and integration of the semiconductor industry with government bodies and research and innovation institutions. ABSEMI promotes the development and strengthening of the national chain of semiconductors, from the design to the chip manufacturing, increasing competitiveness and the attraction of new investments. Always guided by principles of free competition and ethical, transparent, and fair relationship with the government, its members, and the society. Its members are established in all regions of the country, producing what can be considered as the most advanced in microelectronics and heavily investing in research and technological innovation.
Good afternoon, everybody, and welcome to the sponsor session of Chip in the Fields 2021. So at this session, we will present talks given by our sponsors. So they have set up interesting subjects to discuss with our audience of Chip in the Field. As you have seen probably in the program. So in the program, we have a sequence of 7 presentations, and we will start with the first speaker, which is Wim Sawyer from Flanders Investment and Trade, located in USA, San Francisco area, and he will talk about the semiconductor industry in the heart of Europe. So he is in the US, but he will speak for Flanders, so in Belgium, that's part of Belgium. So please, Wim, take the floor for you.
Thank you very much, Professor Schwartz. Flanders Investment and Trade is very excited to be part of this conference. We hope to be there physically next year. And as economical diplomats, the role of me and my colleagues in our Sao Paulo office is to stimulate the relationship between Brazil and Belgium. And we strongly believe that our joint passion for chip design is the perfect foundation for things to build upon between our two countries. So therefore, I would like to ask a moment of your time to highlight some of the industry strengths we have in Europe concerning semiconductors, strengths that are converging in our highly internationalized and cross-border region of Flanders. And as a true ambassador of Flanders, Professor Schwartz himself has intimate knowledge of our region, but in this new age of restricted air travel, I'll start with some brief context for those among you that have not yet had the chance to visit Belgium. So I'll start with a short map of Europe. If you take a closer look, you can see why we're considered the heart of Europe. The dark gray triangle is the country Belgium, and the top yellow part of the triangle is the region of Flanders, something more or less 6.5 million people. Now, as a mid-sized country in Europe, Belgium is highly and densely populated, and it's highly hyper-connected to the neighboring countries, Germany, Netherlands, UK, and France. Our regional capital is Brussels. It is also the capital of our country, Belgium, and is also the capital of Europe. And the European Union has its European Commission based out of Brussels. So that by itself leads me to say, honestly, we are the heart of Europe. And And you might know us from all the political news resulting out of Brussels, but that's not all we have to offer. We're not only a political capital of European Union, we're not only the geographical heart of Europe, but we also have a lot to offer on the technological side. And that is something that we do not promote a lot, hence our participation in this conference and our contribution to the Chip in the Design conference. So enough with keeping a low profile on high tech. The next couple of minutes, I like your time, and I would like to show you how that on the economical and the technological sides, we're also the heart of Europe. And in the past few months, we have been able to change that perception. And if I move to the next slide, I'll selected 2 screenshots for you of recent press items that shows you the position that we have in Belgium when it comes down to 2 of the most pressing global issues at the moment concerning high tech. The first issue is the shortage of vaccines, and the second issue is the shortage of semiconductors. So in both these domains, we play a role in providing a solution to the world. And when you look at the biggest vaccine production deal that has been made, it's the European Union ordering 1.8 billion vaccine doses that are produced in Belgium. That's on the right side of the slide. You see a screenshot there of the European president of the Commission visiting Flanders and the Pfizer production sites that is delivering 1.8 billion vaccines. On the left side, you see our role that we play in providing a solution to the semiconductor shortage. I will not cover that a lot, and I'll leave that to our next speaker from our distinguished researching organization, IMEC, to cover that topic. Moving on. So when we look at the global value chain of semiconductors, I not need to tell you that there is a particular focus in particular steps, starting with the design, moving to fabrication, going to assembly of the chip package as a total. And all these steps in the process have particular suppliers. So what I would like to do today for you is to give you a brief introduction, which kind of industry references that we have, which kind of players in which part of the global value chain have a presence in Belgium, and what do they do there. So when I overlay this figure of the global value chain with some of the key references, both the European one as the American ones, you come to the following image, where in yellow you see some of the key European players that have a presence in Belgium, and in gray you see some of the key American players that have a presence in Belgium. So starting with generating IP and knowledge from IMEC, going over software where we have Cadence and Synopsys present, all the way to producing chips even. We have foundries present in Belgium as well. And all the way to assembly, we have particular references that give an idea about the strength that we have in semiconductors. So, for example, AMD has a regional headquarters in our region, and also Intel is present with supercomputing, as well as ON Semiconductor with silicium production and wafer production. So in short, I think that the one thing I would like you to remember is in Belgium, in Flanders, there is a very high percentage of the global value chain present, perhaps with the exception of the assembly part, which is traditionally more done in Asia. So, but apart from that, we even have equipment and tool providers that have ambitious presence in Belgium, and we have material providers as well. So these are the references from the industry side when we look at investors, but we also complement that with some homegrown chip design houses. And that is what we like to summarize as Fabless Flanders. I would like to give you a very boring enumerated list that is not exhaustive, but that is giving you an idea about some of the design competences that we have. I grouped them in technological expertise, And each of these links is a particular design house present in Flanders. I invite you to take a closer look after this conference and to go over these companies. I'm pretty certain you will find a good partner for your research or your company in Flanders. So these are young companies varying from maybe a couple of employees all the way up to 350 employees that are headquartered in Flanders. You see that on the digital and imaging side, there are a number of companies, security, 5G, analog and communications. Even the material side, we have young companies that grew into global presence, and on photonics and design services as well. Now, some of these young companies at a certain moment are acquired by the bigger players. And that is particularly the case in the EDA software field, where we've seen a number of acquisitions, for example, by Synopsys or by Cadence, and also Siemens acquired a company in Belgium that was active in this EDA field. So we consider that the best proof and the best testimony that our people in Belgium are very expert, very state-of-the-art in what they do. And sometimes when they want to continue with their growth, they need to find shelter underneath the wings of a larger company. So please take a closer look at this list and you'll definitely find a partner for your research. Many of these, by the way, grew out of academic research labs or applied research labs or even corporate spun-outs. So they're very into research, although they're very commercial at the moment. They still publicize papers and they still collaborate highly in the academic research field as well. When you combine those two, and when you combine the young fabulous companies that we have, which is depicted here in yellow, with the foreign investors that we have, which is depicted here in gray, you come to a very high dynamic of an ecosystem that is basically our strength in chip design and semiconductors. So these young companies that we grow together with these investors that have ambitious R&D teams and ambitious commercial presence, they create a particular dynamic, which is the secret recipe for our success, and which is why Flanders as a region is considered to be in the top 3 in Europe as a whole. In Belgium, in Flanders, we're very open and innovative in the way that we try to advance the state of the art, and the presence of all these foreign investors is a testimony to that. Now, to give you an idea, the University City of Leuven, which is on the center of my screen here, versus the University City of Ghent, if you take the distance between these two cities, it's more or less the distance growing from Unicamp, where Professor Zwart is, all the way to Sao Paulo. It's a short drive, depending on traffic, of course, but it's 70 miles to give you an idea. So all of these companies, all of these cities and universities are very close to each other. And even when you look closely over the border and you look at Germany, for example, the city of Aachen, where semiconductor companies like Aixtron are present, or you look at Eindhoven, which houses the largest technical university of the Netherlands, or you look at Lille, which is the largest student population in France. All of these, they also contribute to our ecosystem in Flanders. And we're very happy that we have all these neighboring cities of our neighboring countries part of our ecosystem. Moving on, I would like to give you 3 examples. These were just logos and maps of Europe and maps of Flanders. But as this conference is called Chip in the Field, I thought, okay, the name comes from Campinas, but maybe I can give you some examples of Flemish designed chips that are in the field and that are in use. And I'll start with my favorite personal story here is that we have a number of people and design houses in Flanders that are highly expert in CMOS image sensors. That team resulted out of IMEC a number of decades ago. And those companies that they created, they were acquired by companies like ON Semiconductor or by companies like Astro Microsystems. Now, when you look at the chip in the field, this is probably the best example I can give. This chip is on Mars at the moment, and it's not one chip, it's several different design chips in Belgium, in Flanders, that are currently on Mars in the NASA Perseverance rover. So you see an image of the 360-degree Mars landscape in color here. That image was the first one to be transmitted earlier this year back to Earth, and that was done by a Belgian image processing chip developed by the CMOSIS team. CMOSIS that is now acquired by Austro Microsystem. So it's a global shutter kind of image sensor, and it has a very wide field of view versus the more traditional 45 by 45. It has 90 degrees by 70, and it's a number of sensors, 20 megapixels each. And by having 5 of them stitched together, you can create this high resolution view with very much detail like you see on the screen. And that is not the only chip. There is another chip that is on the NASA expedition on Mars, which was used for the landing. In the final descent, when the parachute dropped the rover, there was a camera pointed downwards to the Mars landscape that was also imaging, and that helped to accurately position where the chute was versus the image of the landscape of Mars. So these 2 chips in the field, in space, are Flemish designed, Belgian made. We're very proud of that when they touched down successfully on February 18th of this year. And finally, that's not the chip, but also the parachute was made by a Belgian company, Picanol. And for the engineers among you, in this parachute, there was a hidden message. And the hidden message you can see on the right, it says, "Dare mighty things." Followed by the coordinates of the research organization, the NASA Jet Propulsion Lab here in California. So this is the first example. A second example is a company in Belgium that makes automotive chips and sensors called Melexis. That is one of those young companies that grew to a global corporation. And currently, when you look at a car, it has on average 13 sensors from this Belgian company called Melexis. They were very early in making solutions for the electric vehicle market, and they have been highly successful in the last number of years. So this is a chip in a car that is Belgian, made with international talent, of course, but the company is headquartered in Belgium. And the last example is a Belgian chip in displays or in projectors worldwide. In Belgium, we have a company called Barco, headquartered in Kortrijk. It's a multinational company employing more than 4,000 people, including a very ambitious presence in Brazil, in Sao Paulo. And they make high-end displays and high-end projectors. They're the world leader in that, especially when it comes down to digital cinema projectors. And they were the first to successfully commercialize a Texas Instruments DLP chip. For you that are familiar with the technology, it's basically a chip full of tiny mirrors, where every mirror is a pixel. And when you use these kind of chips, you have a very sharp image that is being used in movie theaters, including in Brazil. And making those projectors, you need a lot of chips around it, both field programmer gate logic, but also ADC and DAC converters for all the cables and the standards. And this Belgian company was the first to successfully commercialize that. So when you're planning to go and see the James Bond movie soon, later this month in Brazil, the chances are 90% that you'll be watching it on a Belgian projector and a Belgian screen there in Brazil. So that being said, I would like to invite you to consider partnering with Europe, partnering with Flanders. We have a local office in Brazil, in Sao Paulo, headed by Dirk and headed by Claudia for investment. And I included her contact details here. Please feel free to reach out. Even if it's research, even if it's purely academic, we're here to help and to stimulate this relationship that we have. And with that being said, I keep it to the time, and I would like to give the floor back to Professor Schwartz and to the next speaker, Paul Malisse from IMEC.
Okay, thank you, Wim, for this nice overview about Flanders. Very interesting. Maybe we have some time, a few minutes for questions. If there are any, please type on the chat. Meanwhile, maybe I have one question is, you mentioned the shortage of vaccine and of chips. Is there also a shortage of engineers, designers? Are you aware of that?
Good engineers are always hard to come by. I think it is as relevant in Brazil as it is in any other country in the world, and especially in the innovative hotspots that we consider ourselves to be part of. I think there is a high presence of talent available. People are very science and technology oriented in Belgium, which leads to a lot of students graduating in those fields. But for the right kind of company and the right kind of technology, I think any engineer or scientific profile is definitely very convincible to work for you, and even very mobile as well. We have seen Belgian talent that went to work across the border to Eindhoven, for example, or that were lured into Silicon Valley here in the US. But after a number of years, they gain invaluable experience and they bring it back to our ecosystem, which is why I mentioned that we're very open to other cultures and open to other languages and open to foreign talent, because it's the secret of our success, being able to attract engineers, to send out your own profiles and to get them back after a number of years. I think the secret lies in the in and outflux of talents.
Okay, thank you. I don't see other questions. Maybe Rafael, are you looking to the YouTube? Because I don't see the YouTube here. I couldn't enter. Otherwise, we leave these questions for the end, if there are, and then we go to the second presenter.
Jacobus, there is a question in the chat now. There are no questions in YouTube so far.
Question: how do you see the future of the industry with the new climate policies in Europe? So climate.
Thank you for the question, Eduardo. Very relevant question indeed. So from the Flanders perspective, in our outreach towards the world, we have 3 priorities when it comes down to technology. And it's summarized as following: it's digital, it's health, and it's green technology. So on these 3 fields, we're boosting our efforts to collaborate with other countries, and we're also doubling the amount of diplomats that we dedicate to those fields. So climate is definitely a priority for Flanders, for Belgium, and for Europe. And as you know, most of the solutions that need to be energy efficient, they result in using more and better chips and better designed chips. So for me personally, I see this as a converging field between semiconductor experience and between climate policies and so forth, and ambitious to become greener. I am very hopeful that there will be more public R&D funding for both the green field as the semiconductor field in the nearby future, for companies from Brazil to leverage upon when they consider an entity in Europe, for example.
Okay, interesting. Thank you. Okay, so now I thank for your presentation and your answers, discussion. So with that, we go to the second presentation by Paul Malisse from IMEC, that is stimulating and supporting the local semiconductor ecosystem. So I know Paul for many years. We worked together for some 5 years at least. So it's my pleasure to have Paul here out on the stage. Paul, go ahead. Have the floor. Are you there? On mute, maybe?
Yeah, I think I should be hearable now.
Yeah.
Okay, good. So thank you, Professor Jacobus, and for giving the opportunity to talk today. And also, of course, thanks to Wim to already pave my way. It makes my task a bit lighter because you have really perfectly set the scene. And I can, I think, seamlessly attach to your talk and explain a bit more about IMEC, what we do and what we do in general, also for the local ecosystem. Okay, let me start with a few funny titles that are let's say coming or showing all over the place the last let's say weeks about chips. The shortage is more than potatoes. Chip makers reallocate wafer capacity to ease global chip shortage for vehicles, and then the car us for hoarding toilet paper. Clearly there is something going on, and I think all of you have basically seen so there is many reasons for the current let's say shortage and of chip shortage, and of course the car makers do play quite a role in that, but the conclusion is that basically we start to feel it everywhere, not only on the, let's say, the chip market for semiconductor or for cars, which we see in the media, but even when you want to buy a washing machine, we start to get our washing machine, and so semiconductors are all over the place. And if we look a bit back from the first wave of industrialization, it's impressive and remarkable to see so many decades later, in the 2000 area 2000, we're still making more and more disruptive applications, needing disruptive developments, disruptive ASICs. And if you think that well, we need to go much further now, based on deep technology, AI, 5G, Industry 4.0, automotive, basically shows that semiconductor is blooming. And we were just talking in the talk of Wim about talent, about the shortage. Well, basically my talk is also about how can we support that talent, how can we bring that talent to the market. So when I say that the semiconductor is basically blooming, well, it's not only look at the big guy. Also, it's not only for the bleeding edge technology. Look at the media, EE Times will typically report on 16 nanometer, 12 nanometer, 5 nanometer. Only for the high volume applications. Again, the big guys, they do things in advanced technology for high volume. It's not all, let's say, big and extremely advanced technology. It's crazy to see so many going in mainstream technologies. And mainstream is like 0.18, 60 for today. Is blooming once more, and we do see this also by the fact that there's a lot of startups coming in mainstream and also in, let's say, more advanced technology. And IMEC is contributing in different ways in that story, I would say. Probably most of the people will know IMEC as a pure, let's say, hardware R&D house, focusing on scaling on transistors. Well, that's primarily true. Let's say we have been focusing more on applications being enabled by this technology, by this let's say, scaling technology, the scaling packaging technology, and so on. So as it probably could derive from the talk of Wim, IMEC is headquartered in Belgium. We have been growing to a worldwide company. Basically, we have about 5,000 people these days. Headquarters in Belgium, but we have different representations, and we have also different places where we also host. We have a significant in-house center working on wireless for wearables, typically. We also have a new activity in Nijmegen, focusing on basically, what we do there is focusing on the Internet of, let's say, more agriculture, Internet of water, contributing to, let's say, the better the society changes of these times with technology. Yeah, and then we have, of course, representation in Japan. Forget we have in Sao Paulo, and Professor our contact there. So this is where we know each other very well from. But later on, you will see that Jacobus has retired from that because he needed time to organize this conference. And today we are having a very strong collaboration with Jose Escudero, which I will present to you in a few slides. Yeah. So besides the R&D, as I mentioned, we have two important activities. One is venturing. So one mission we have at IMEC is, of course, to create startups and to bring value to the local ecosystem, to create startups and so on. So that's one big activity next to our R&D. Activity, a big important one is an activity which we refer to as innovation services. Yeah, and that's basically the team that I am part of. And in this group of about 200 people, we try to turn ideas into reality in specific way. Yeah, our group is basically called IC Link. Yeah, and we are a bit a special beast. Yeah, we're not doing R&D again. R&D, it's the industrial window towards the industry, so to say. Yeah. So the mission of IC Link is basically route to any kind of production, high volume, low volume of an ASIC. Yeah. And it's very important to say that we offer this both to academia and industry. Initially, academia was the prime suspect, you could say, but as a natural consequence, a lot of industry players have picked this up, so that we were really providing an interesting service there. And as such, we have been growing together with the industry to a level where we are today, where we have a very strong offering towards academia and industry. And Europractice is a key word in that. If you look back in how we started to do this activity in the support to academia and industry, it was started based on a European project called Europractice in the, let's say, early 90s. Yeah, and Europractice is a service. It's not a legal entity. It's a service offered by 5 partners, and probably, you know, most of them. IMEC is leading the project, and there is the STFC in UK, Fraunhofer in Germany, CMP in France, and Tyndall in Ireland. Yeah, and together we are basically running this project, Europractice. Now, what is Europractice? Well, it's basically a service to stimulate and to provide, let's say, tools and training for academia. This part, the tool part, is basically dedicated to Europe, because there is the tool vendors involved, and there is a kind of a European component there. Now, all the rest, let's say, the ASIC and the technologies for assembly, the prototyping, the volume manufacturing, all of that is basically available for anybody worldwide. And the simple reason is that to be able to bring a service which is sufficiently relevant, which is sufficiently based on state-of-the-art and even top-notch technology, you need to have sufficient players to work with. And by, let's say, opening this activity to the broader world, we have a much better offering. Yeah. And of course, the final idea is, as we already mentioned in the earlier talk, is impact for the industry, skilled engineers, stimulate collaborative research, and stimulate startup initiatives, not only in Europe, by far not only in Europe, but worldwide. Yeah. So what do we bring to the ecosystem? Well, there's a few things I want to mention. I will not dwell too long on that, but technology selection. I mean, it's very important for anybody, even an academic research institute starting a new project, but a startup company also, to find the right technology. Yeah, and there is a lot of parameters that play a role that we could discuss in big length. Why do I need this technology? Well, here are a few reasons on the screen. I will not, let's say, go through all of them, but of course, you need to know, you need to understand whether it is analog or digital. Yeah, or what's the lifetime of your product. Will you need high volume Do you have specific processing speed requirements? Are you bound to export regulations? So there's a whole series of reasons that probably most of the, let's say, the people that need ASIC technology are not fully aware of. Yeah. So there, of course, we can assist to provide the indication of what is needed. Well, different customers have different needs. We have different customers as academia and as companies. Academia, typically, they are looking more into doing the design themselves because that's really their IP. Yeah. For companies, well, they really focus more on really what is their expertise. They could have an expertise on RF as a startup company, but they might need activities to support some digital let's say integration and so on, for which they don't want to invest in tools, don't want to invest in let's say in people, and they don't have the experience. So we try to really let these people focus on what they do best and bring additional service. Yeah, this is, for example, also something that is often used by startup companies. Some design service, some implementation. Implementation is what you call architectural. That is more used by, let's say, typically system houses. System houses in the inside of the ASIC, but more on the specification side. Yeah, and this is where we also can help to bring them into contact with design houses that can take this, let's say, conceptual part. Long time ago, NPW is the focus is to offer a cheap way to prototype to manufacture to enable to prove that your part is working and that it is a valuable part to go to production. Yeah, and then there is different opportunities or let's say options to go into production. You can do an MLM. An MLM is somehow a vehicle to produce more devices, but still have more flexibility. It's a bit, let's say, wafer manufacturing process. And some foundries are still offering it, some foundries are pulling it back. Yeah, so we had in the recent, we see a massive overload in all the factories. Some key, let's say, factories have reduced their offering in that sense that they are taking away MLM because MLM is having an impact on the throughput of the factory. So that's something which is a pity. Yeah, for example, TSMC stopped their MLM offering because, let's say, support the worldwide. To give you an idea, for 2021, TSMC is facing a shortage of 3 million 12-inch equivalent wafers. Knowing that TSMC is the biggest in the world, they have this massive shortage is quite impressive. But it ripples through. So this shortage ripples through in some of the other services which are still more on the development side. Yeah. So of course, but in the end, I mean, MLM is intermediate. You would go to, let's say, a full mask set when you are full mask set, and a full mask set can depends on whether the technology is advanced, like 60 nanometer, or more mainstream, like 0.1 is to be used forever. Yeah, but it's clear that customers having a special niche product, it's not that easy to buy a mask set of $1 or $2 million for a low volume. Big foundries, they always think in infinite volumes, and they see NRE, a mask set, cost as neglectable because they say, okay, you're going to sell 1 billion components anyhow, it will depreciate. Always the rationality we can, of course, follow, and this is what we're partnering with a lot of these foundries to also make them understand, look, not everybody is looking at 1 billion for a product. So, well, of course, again, every customer is different, and there is additional services that those customers need. Packaging is one of these. Yeah, also there we provide expertise, we provide support, we provide implementation, depending on what the customer needs. Yeah, sometimes they need really just some prototype. Sometimes to really to go to production, and I think it is important. Packaging was relatively straightforward. Yeah, your ASIC in a box, and the innovation was the ASIC. I dare to say that's not true anymore, because today most of the packages are really complex. Yeah, and they are part of the innovation itself. Yeah, if you see what we can put together in a small package by System in a Package by TSV, it's really immense, and this is really enabling. Also means your package stage. Some customers, again, less these partially relevant for R&D institutes, but fully relevant for companies that want to go test your device in a fully repeatable way. Yeah, meaning you want to have operational devices, working devices, and you want to be able to trace an ID of a device to see when it fails what is happening. So that's what we call a test development. Of working in the next couple of weeks, depending on the mission profile. Yeah, that you can use to do this kind of validation. Well, who are our customers? And I want to show here that it's by far not only Europe. As I mentioned at the beginning, we need to consolidate the whole ecosystem, all, let's say, regions, to have sufficient heavyweight to be able to go to big partners to say, look, we, for example, IMEC is, or bring together, yeah, at least with, not only in Europe, about 20 R&D centers of all types, worldwide, some companies. So here you see the pie chart, which was basically a chart in 2020. The Americas part is also growing significantly, because we have more representation also in, let's say, North America these days. Now, if well, the take up, if you look at on an annual prototype on an annual basis, industrial, we are prototyping on average in a year, 900 different circuits, as you can see in many technologies. But the high, let's say, the high runners here are UMC, TSMC, Global Foundry, and ST. But by far, it is part of adopted. Too big, it is a massive chunk of the pie, and I mentioned before, 0.18 has been, because it's a very good technology, it's a very cost-effective technology, it allows to do a lot of things on RF, and it's really amazing to see these days still really disruptive applications which go in very high volume on 180 nanometer. That's the reason why, if you look around in 8-inch technology, worldwide, all the factories are already full, and nobody has had thought 20 we would still being taped interesting circuits on 8-inch. The next big one is 65. 65 is one of the technology MCUs, automotive MCUs, which is causing a lot of trouble these days in the semiconductor market, in the industry. A few other interesting ones are photonics, growing significantly. 28 nanometer probably going to be the next big node. So they say the older technologies are slowly fading out. Some of the older, for educational purpose, more advanced technologies, or they're more towards application. So from IMEC side, I want to mention also that we are leading activities towards on semiconductor X-FAB, UMC and TSMC. So this is their expertise, and the other technologies are managed by our other partners. Now, almost at the end of this presentation, I want to mention again, and looking again at the full custom ASIC development flow, is that we have quite some different stages in the flow. We try to be a single point of contact where needed, but in many cases, customers pick a bit like a Chinese menu. Yeah, they want to focus on what they're good in, and they need expertise for some parts that they would like to outsource. This is basically what we do. So in many cases, universities, they just need, let's say, manufacturing and packaging. Companies and system houses, they need much more. And this is where we basically try to assist. So I mentioned Professor Jacobus. I also mentioned Jose Escudero, that started to work with us since, let's say, early this year, following up after the retirement of after Jacobus. So I feel we have quite a lot of a good network and a good partnership in Brazil, thanks to Jacobus and Jose. Now, just to wrap up, I want to mention two things that we are currently pursuing in Brazil. So the last years, mainly with the drive of Professor Jacobus, we have been offering specific incentives for Latin Americas. Yeah, and so we have been offering free mini ASIC fabrication, partially academia. Yeah, and Paul from Jacobus, he has a website where he's maintaining, let's say, the results of that. But it's interesting to we have, let's say, almost 150 students involved in these mini ASICs. We have 40 and probably in the meantime more papers that have been originating from this free mini ASIC program. So that was very successful. It was on a mainstream node on 0.18, and of course we would like to see this evolving to more advanced technology. But I can only, this was very helpful, Professor Jacobus, to also to put all, say, reviews in place to stimulate, to chase me, to chase the IMEC team to help make this happen. It's always very intensive, but it's good to see that we have fantastic results. And last but not least, and this is my last slide, basically, the work we are doing today with the help of Jose is we try to bring together the whole local ecosystem with different stakeholders and to the, yeah, basically you can see here everything you need is there. So we have the design, IP, foundry. We have a lot of local, strong local. You have Chipus, you have Eldorado, IDL, SI. So typically, so there is a lot of, let's say, the traditional strong partners there. There is a packaging ecosystem, and of course, there is people that are sponsoring or can sponsor or will sponsor. So we're trying to set up an ecosystem to trigger some more, let's say, local developments that can and easy with somebody who has a fantastic ecosystem. So listening, of course, we're very happy to take any question about this. If not today, please reach out to Jose or to myself. I think we can do a lot of things together, and we know Brazil also contribute to that. I think just
okay, thank you, Paul. We had a problem with your connection, so your once in a while you disappeared, your voice, but I think the message went through.
Okay.
And also the time was a little over.
Okay, sorry.
So I think the questions really we leave it for emails to these your emails.
Okay. Thank you.
But anyhow, the mini-ASIC, the free mini-ASIC for Brazil universities is of great interest, great help for our ecosystem. And I think IMEC, the work you do in Brazil is very important for the design houses and universities. So it's
okay.
Good to hear you keep working on this, and
yeah.
we go further. Okay, thanks a lot, Paul. Maybe at the end, if there is time, we can have some discussion, more discussion. But at this moment, I think we go further to the next presenter. The next presenter is Mauricio Kobayashi from Keysight. His presentation is about accelerating advancement in the lab and classroom with Keysight. So please, Mauricio, take the floor.
Can you hear me, Professor?
Yeah, we hear you clear.
Good. My name is Mauricio Kobayashi. I work at Keysight Technologies. Today, I will talk about how Keysight has helped the professors and educators in accelerating advancement in the lab and classroom. My presentation has more than 30 minutes to spend to present. So, Professor, please feel free to interrupt me if I exceed the 20 minutes. I will try to speed up, but feel free to stop me when the time comes, okay? I will alert all the attendees that my presentation will be available in this website, connectlp.keysight.com/ship in the fields, the line virtual presentation, okay? Today, COVID has just accelerated the innovation of learning. So in the classic models of all the students, all the engineering students watching the professor or the educator, this model has become a hybrid model with online classes and plus presential classes. And this is a kind of evolution to maybe 4 or 5 years from now. We'll have implementation of holograms in the classes. So innovation is completely revolutionizing the education industry. Over that, professors also has the challenges. The high-level management of university always ask concern about the ranking of universities. Professor receive a pressure to always be innovating research breakthrough. And over that, also professor and educators, researchers must be aligned with the industries to guarantee the student employability. What the industry is seeking now, okay? So the industry is seeking for more efficient, energy efficient chips, better sensors, better digitizers, better imaging, better everything to have a connected world. So smart devices, smart cities, smart energy, autonomous cars, and aerospace defense also working with better wireless communication. So this is one of the ideas to have the academia aligned with industries. Okay, if you do that, maybe we may, the researchers can make an easier way to get, for example, grants budget about $600 billion in R&D of industry. For example, only in 5G market, it's expected to have $1.2 trillion of business. So the connected world, the smart world, will receive a lot of investments in this decade. Keysight also is aligned with this movement of the market. So Keysight has focused their investments in the wireless communication, in the autonomous cars, the electric cars, better secured world with aerospace and defense systems, besides more efficient infrastructure with networking and cloud, besides IoT. One example of the test and measurement instrument launched to help such evolution is the oscilloscope, 110 gigahertz oscilloscope, which has helped the development, the design of 800 gigabit Ethernet communications. Okay, so what Keysight helped, for example, for education, for educators? Usually laboratories, every laboratory engineering lab of a university has some basic instruments, okay, and they have used design software like AGS for design of electronic circuit, mainly RF circuits, okay. So what we invite all the educators to reach Keysight authorized distributors to check the latest launch of new oscilloscopes, new power supplies, new multimeters, new waveform generators, aligned with latest trend to have all automated, all connected in the lab to allow in laboratory in front of the instruments and remote laboratories as well. And several universities like Unicamp, like University of São Paulo, also have assigned the educational agreement with Keysight to have access to most complete EDA software like AGS, Genesis, and SystemView. Okay, and Keysight also has offered to universities some learning kits, mainly focused for Internet of the Things. So using technologies like Zigbee and Bluetooth. So learning kits also have helped educators to have more efficient laboratories. Okay. Let me so share then solutions of Keysight for researchers. Okay. These are some of the areas which as we consider hot topics for researchers that may be better aligned with the market. Let me share a little bit more in terms of measurement science. So in terms of new materials, we have offered impedance analyzers, network analyzers, SMUs, more and more millimeter wave instrumentation, terahertz characterization device like network analyzers, spectral analyzer, and signal generators are being used, and more oscilloscope and vector signal analyzers have been used for next generation communications like 5G and 6G. Okay, as we said, more energy efficient devices also are developed, and then DC power supplies, DC power analyzers, current analyzers, and semiconductor analyzers are demanded by researchers. And last but not least, the solutions for digital photonics, like solutions to monitor and design current optical transmission, and the tunable laser sources and the polarization analyzer are also demanded. This is some of the instrumentation for design of new materials, like graphene, gallium nitride, silicon carbide. So usually customers use semiconductor analyzers, SMUs, and impedance analyzers, oscilloscopes, and LCR meters to have this characterization of materials. The main solution for such area today is semiconductor analyzers and SMUs, but it's good to check also some launches, like Keysight has just launched the new models of electrometers and picon perimeters with capability to measure current as low as 0.01 femtoamperes, and with capability to measure impedance or resistance up to 10 petaohms. Okay, so if you have need for such instrument, please contact us. Okay. More and more research has been done also in millimeter wave. In the past, aerospace defense area were the key driver of this technology, but more and more autonomous radars and 5G and 6G has driven such technology. I have just attended the ABINE conference today, and I heard from Anatel about the frequency to be allocated for next generation of the communication 6G. Most likely it will be in a range of 240 gigahertz. So more and more research will be done in millimeter wave and terahertz area. So in such research, spectral analyzers, network analyzers, and signal generators are demanded. This is a sample of the instrumentation that is needed for such research. Okay, this setup is very similar to one purchased by University of São Paulo with grant from FAPESP, working up to 110 gigahertz. Okay, so more and more researches on hundreds of gigahertz will be demanded in the near future. Another area with high demand from industry is solution for electrical vehicles. So from the battery management systems, from the protocol to charge the cars, the charging stations, all the electric grid to feed this new market. Okay, so for every area, Keysight has solutions for research. In the, I think 2 or 3 years ago, Keysight has bought the leader in charging station test. That name is SignLab. So we have much more complete solution to allow the design and development of more efficient electrical vehicles. Another area of it's considered a hot topic by industry is the area of the digital photonics, mainly with demand of virtual reality, more and more people connected in their smartphones. So data centers are demanding more and more powerful data links. So for such area, optical digital photonics area is very important. So measurements like return loss, insertion loss, spectral measurements, polarization, eye diagram, and mainly jitter analysis are very important for next generation solutions for 800 gigabit communications. Okay, so these are the main solutions that the devices that market is seeking: optical modulators, optical transmitter, receivers, fibers, and then for such solution, Keysight has a complete portfolio of the products for this area. Okay, Keysight also has signed some agreements to offer on-wafer photonical C research with a form factor and physics instrument to provide solution for on-wafer measurement. Okay. The last area that I would like to point out is the quantum technologies or quantum computing. Keysight has several investments acquired this companies like the spin-off from the Institute of Photonic Sciences from Europe. So Signadyne, Keysight has acquired it to increase our portfolio of test solution for quantum computing. Another company that Keysight acquired is a spin-off from MIT named Lebur to allow more and more quantum research in cryostat temperatures to get more research in this area. So Keysight really bet that quantum computing or quantum engineering is more and more hot technology to be demanded by researchers in the next years. Okay. Keysight has created some new brochures to help researchers to find the right solutions, right instrumentation for these areas of advanced material, terahertz measurement, 5G, healthcare, quantum. So feel free to click on the presentation and download the brochure or contact Keysight representative. We have the representatives are concentrated in São Paulo, but you can reach us. You can see my email, my phone number. You can reach me, and please. I remember all that this presentation will be available in this link. Okay, so that's it. Thank you very much, and I now pass on to Professor Jacobs again.
Okay, Mauricio, thanks a lot for a nice presentation and all the tools Keysight has to help universities and companies to do better work and to know what they are doing. So that is very important. So
thank you very much.
Yeah, we have some minutes for questions. If there is anyone. Okay, I see here a comment by Wim Sohir. So Keysight is also an appreciated investor in Flanders. Thank you, Mauricio. So yes, very interesting. Good to know also. And from Sergio Bampi, also, thanks for the presentation and the presence of Keysight in Brazil. I think is very important. We have you here. So about quantum computing, does Keysight also work on it or develop solutions, or mainly the instrumentation for measurement?
Yes, mainly instrumentation. So the laboratories usually uses digitizers, arbitrary waveform generators, local oscillators, spectral analyzer, and oscilloscopes. So these companies that Keysight acquired are specialized mainly on sensors and software, automation software, to allow give more results and data. How can I say, masticated data for the researchers to allow them keep moving in quantum computing. So this is the main idea of the companies acquired by Keysight.
Yeah. Another comment by Sergio Bampi. From the old times, HP to Keysight, this company have had a good presence in Brazil. Yes. HP used it to have manufacturing in Campinas, I believe.
Yes. Sometimes, yes, long time ago, HP had a manufacturing plant, and also HP had acquired the Compaq long time ago, and they had the manufacturing plant. And very long time ago, I think in the 80s, Keysight had a local some manufacturing in Rio Grande do Sul, but I think it's in between 70s and 80s. But now our manufacturing plants at Keysight are concentrated in Santa Rosa, United States, Böblingen in Germany, and Penang in Malaysia.
Okay, thank you.
Yeah, I have several customers that calls me Mauricio from HP. Yes, it's okay.
Okay, with that, I think we thank you for your presentation and participating
thank you.
in this session. Now we go further. Next presentation by Rosana Casais from ABCM Brazil, with the title, I have it in Portuguese, but Opportunity and Perspectives for the Semiconductor Industry in Brazil at Post-Pandemia. But yeah, so Rosana, please go further. The floor is yours.
Thank you so much. It's a pleasure to be here representing Brazil's Semiconductor Association. Just some comment. Yeah, HP was closed on 1992. I used to work over there and start to work on semiconductor after there once the company was closed. Well, really long time ago, but let's move on. The idea here is trying to discuss and present some opportunities as we can figure out, and we may see we are hearing a lot. I saw before on the partner presentation that semiconductor nowadays is hot. All time we open the computer journal, so on, we can see some notice talking about the shortage and so on, about cars and so on. So let's try to see how all this the situation and environment can and is trying to change the environment in Brazil. So let's move on. My presentation is not moving. Okay. Just to present you my Semiconductor Association, ABCM, we was found 7 years ago. The idea is trying to represent the industry we already have here, and more than industry, also we have a lot of university and that are working together. So nowadays, all the factors that are here, some design companies here with Smart and Idea, also our associates that are going to talk in the future on the sequence. And also the idea here is try to have one channel to discuss public policies and trying to represent what's good and analyze how the Brazil semiconductor can move on in order to make it more strong, and trying to discuss not only the business but the policy and all this financing and how we can move on. We know this is a very hard industry, so even we have some technical issues, we also must be paying attention on how the environment, business, and so on can be changing the way to do business in Brazil. So this is ABCM, the way you used to get a very fair way to discuss, because most of them are competitors, but we used to say that free competition, integrity, and respect are main way to discuss and move on. Just to give some idea about the market nowadays, because Brazil is very interesting, because we used to have almost a closed market here until now. So because informatic law that they used to say how we could have some better tax incentives and so on to move on, we have here after, and it was interesting to talk about HP in 1991, but this was exactly when the market in Brazil was open abruptly, just one time. So after that, the informatic law started to move on to reconstruct the industry in Brazil, the TICs. And nowadays, we are lost a lot of design and so on. We are trying to bring it back, but we can see that the market is already strong. We have almost 50 of the most biggest industry in Brazil, that Dell, HP, Lenovo, they are all located in Brazil. So this brings some strong opportunity to the companies that are here located. And because we also had some other laws, we already have a lot of operation on semiconductor area in Brazil. As I mentioned, it was interesting because I also was interesting about to bring to you all some of a newspaper. What we may see it is because when we open the nose, what we see? Oh, there is no cars because we are missing some ships. Here I bring, and in the same way we see, oh, now everybody is restarting to put a lot of wafer fab. In 2-3 years, we are going to have more than we need. On the other hand, the other people say, oh, no, because in the same way that we are increase the capacity, we are going to increase the demand. So, but what we figure out also is that the companies, all the semiconductor companies are really doing very good results this year, of course, because when you have more demand, it's what we used to see that they can do better business, but in the same way, not exactly it's good for the environment. So because of this, what we could compare is because what we have in Brazil, because we don't have a wafer fab, in fact, in Brazil anymore, but we have some packaging house that they used to work together, Samsung, SK Hynix, and Micron. Mainly, when we think about Brazil, is maybe the only country that is really managing and using wafer that are importing wafer and industrializing ICs from wafer way. So it's different, a little bit different to try to understand why we are using this, because the policies and so on. But anyway, we can figure out that we are not doing the same kind of business, for instance, on TSMC or ST or this company that I used to supply automotive industry, for instance. So the question we are doing nowadays, why not Brazil try to think about semiconductor for automotive, even doing some back-end operation and so on? When we think about the car, and you can realize with this brief diagram, we see that we have DRAM and flash, that Brazil is state of the art on fabrication, on operation, with not wafer, but back-end operation. So it's something that nowadays the companies are starting to discuss. When we compare, so why we are doing this, because when we think about automotive business and we think about what we are do here on ICT, on TIC sector, what may we do? So it's not so different, it's not so similar, but we are trying to bring, when we compare what we already supply for smartphone, this is much more complicated than on technology way, at least on packaging, than when we discuss about wire bonding or something these that are packaging technology for automotive. Usually we used to say that automotive use some consolidate technology, of course, because of the risk and the challenge that are really put for these suppliers. So it's something that nowadays our factories are trying to analyze and see what may be done. One of the very interesting things to think about is when you have, for instance, an IC for mobile or for automotive, what kind of difference, just to take an idea on terms of lifetime operation, when we do and brings our temperature completely different, and so the specifications are different. So this should be a huge challenge for new entrants for automotive. So nowadays, this is something that really must be considered in the same way. And when we sign from technical to market analyze, also we can see that the future says that the number of ICs into the cars should be growing, and growing mainly because the electric car and so on. So when, of course, we are already established on computer and so on, that is something that Brazil already selected to work on this area, but it's interesting that we try to pay attention on the others kinds, and we see that automotive are projecting to continue growing. When I think some idea about what kind of cars or what kind of components we have into the cars, we have, this was supposed to be just one figure, but one image, but the idea here is try to show that memory already represents 7% that what we have in cars, and memory we are ready to supply in Brazil, except we have to try to fit all the new specifications. On the other hand, Brazil is semiconductor industry are trying to analyze how about MCU, NPU, and so on. Why not to try to study? So try to see what we may do, because of course new investment and so on will depends on the market and the demand. We know that Brazil demand for automotive is still not so big to make, for instance, any kind of I think the idea here is try to, because this is something that in the past used to be, oh, let's supply for local market. This is impossible, not automotive. So to start to think on this, we are trying to think about Latin America and Mexico and so on. So this is the first thing to be considering when we say why not automotive. By the other hand, we need to think why Mexico, how can we fit and supply ICs to Mexico if we don't have front-end operation in Brazil? Why China or why Korea are going to give us in Brazil this market if they are already supplying? So many questions, but this is something that really we have to think about. I think this is something that we have to think. There are a lot of people trying to understand. If we think about Anfavea, in the past, Anfavea is a final manufacturers association, from automotive. And so we have to try to understand how to help this industry, but how to do something that semiconductor companies are going to continue and doing good business in Brazil to maintain their operation in a good way. Thinking about this, and if we talk about industrial policy, we have PADIS. PADIS is a semiconductor program semiconductor that was defined some years ago and was responsible to define what we have today in terms of semiconductor and back-end operation in Brazil. over past more than 15 years, I think we have here a very nice state-of-art semiconductor back-end operation. What you have here, some process moved from wafer grinding and so on, refining, encapsulation testing, some operation design also are already established here. And in fact, Brazil also was losing their front-end operation, but still keeping design and back-end operation. So it makes our people already very well trained in human research to moving on this sector, including automotive. It's very interesting also to watch supplier on automotive repair. So as I told, a lot of new challenges are facing to the industry, mainly because we have to, how we are going to map in partnership, mainly because we don't have a wafer fab in Brazil. So trying to restart and see how to move on independent companies, on the consortium companies on the sector is something that are now facing to new companies trying to move on to try to see how to figure out this to Brazil. But anyway, if you think about technical, if you think about partnership or demand, everything this depends also from industrial policy and PADIS that makes all this operation semiconductor we have in Brazil that we already saw and now we already mentioned. The company was living in Brazil in beginning 19 years. We are facing something not so different if we don't have PADIS benefits renew next year. Just to keep in mind, this program are going to expire most of benefits on January 22. So nowadays, all Subsemi is working together, the Congress and the policies to try to see what we may do on this area. We are very confident that everything are going to move on. This is important for industry, but also important for academy. For we have nowadays from these policies so many labs on universities like we have here in Rio Grande do Sul, together Unicinos and URGS, and also on Instituto Eldorado in Campinas. So we have too many initiatives that are good for the sector, that are moving on and making the very nice environment in Brazil that we believe that must be supported and continuing. So this is something to pay attention with. Well, here is my contact and the website of Subsemi. I invite you all to visit and so on, and try to check what we have here, our associates. And you may see here my email for contact. I will be available for any doubt you have from now on. Thank you so much.
Okay, thank you, Rosana. Very interesting to see this update about Subsemi, the industry for semiconductors in Brazil. We have here one question by Sergio Bampi on this last point, the PADIS benefits assured by the law 11484. Is there any news on possible extension to new projects or to extend current benefits to those already manufacturing in Brazil? So what are the perspectives?
Yeah, just thank you, Bumpy. In fact, nowadays, new products are completely closed since last year. And what are going to expire are some tax incentives like credit and so on, like that are equivalent to PIS and COFINS. But even for all the projects that are already approved, they used to have some 10 years, 15 years. So it depends on the company get the approval. It's start to close year by year, depends on the company. So it's really so important that we try to accept, to develop a new law that accept new projects for sure. We are facing now IoT, we are facing now a lot of products that the companies are trying to start. And also we must make sure that competitive must be assured from even for our old products, already approved old projects.
Okay, thank you. So here a question from Wim Sohir from FIT. Thank you, Rosana. You mentioned that Brazil does not have a foundry fab present anymore. Do you see new initiatives attempt to attract a foundry to Brazil?
Yeah, I think Brazil is very optimistic, and for instance, I'm so sorry about what we are figuring out nowadays with CETEC and what some years ago happens to UNITEC. But anyway, the government is always trying to bring new initiatives nowadays because semiconductor, they are trying to bring more funding. We are working together on this group to trying to see what way we do, because we know that it's much difficult to start from front-end operation. So the idea is trying to redesign how to start some partnership to do back-end operation for automotive, and we start to moving on to the design. But the Apex and the MCT and the economy, they are always working together. BNDES, FINEP, that is finance, that work together, MCT in Brazil. Everybody is trying to redefine, and for me, it's a pleasure to work together, just to trying to introduce. There is a movement called the Made in Brazil Ilimitado that are working and driving by Cindy Peças and Anfávia. And I suppose that on this Thursday, Henrique Miguel from MCT will discuss and give you more details about this.
Okay. Was that what you asked, Wim? Okay, yeah. Good. Thank you.
Yeah, I saw. I'm so sorry also, but we must moving on. Thank you so much.
Thank you, Rosana. So let us move to the next presentation, that is by Rogério Moreira from Smart Modular Technologies in Brazil. And the title is about development of IoT LP WAN devices. So please, Rogério, I see you are here. Can you put it on slide view?
Yes, it is.
Screen.
Can you see my slides?
Yeah, but also with the next one. It is not in the show mode.
Let me share here. Okay. And now?
Not in. Let's see now. Yes. Now it is okay.
Okay. Thank you, everybody, to be here. Thank you, Professor Jacobs. We'll take some time to talk about project that we have been doing in Brazil, here in Smart Brazil. That's the development of IoT LP1 devices. Okay. I'm Rogério Moreira. I'm the Senior Manager for New Business Development at Smart Brazil. Pay attention. I work for Rogério Nunes, that is our president of Smart Brazil. So I'm the other Rogério at Smart, not the main one. Okay. Basically, we are talking today a little bit a review about the operation of Smart Modular Brazil, some news, some new ideas and new things we are doing here in Brazil. We're also talking about the Advanced Package Lab at Instituto Eldorado. And then we'll start talking about IoT. That's a project that we are developing here in Brazil. Okay. So Smart Brazil, Smart Modular Technology is part of the Smart Global Holdings Groups that's based in USA. Smart was founded in 1998. Initially to do is DRAM memory modules for computers. So, and now the company has increased a lot. And exactly now, that is 1 year ago, we have a new CEO. It's Mark Adams. That's the former CEO for Lumleds and former CEO for Micron. And he's doing a lot of changes. And one main change is now we have three focus areas. One is in the Intelligent Platform Solution Group with the base of Penguin Computing Company. We do mainly supercomputers and processing boards and processing systems, okay? And we have the Memory Solutions Group where Smart is located, the original business of Smart. So that we include the operations in United States, operations in Brazil. And more recently, we have the LED Solutions Group with the acquisition of Cree LED. So now we have in the group a second assembly and test operation in China, 2,000 people. So in the past, Brazil used to be the only assembly and test operation for IC, and now for LED we have an assembly and test operation also with the acquisition of Cree LED. Okay. We have several locations. Our headquarters are New York, California. Our main area here in Brazil is Atibaia, where we have 2 factories. And this month we started an operation in Manaus, also a new factory in Manaus. Okay, and of course we have the Advanced Packaging Lab in Eldorado, Campinas. As we have a partnership with Samsung Semiconductor, we also have an office that's linked to Brazil in Korea, okay, to leverage our relationship with Samsung. So the history of Smart Modular Technology in Brazil starts in 2002 when they acquired the NEC Brazil Memory Division that we used to do only DRAM memory modules. In the year 2005, we start doing the construction of the packaging plant in Atibaia. And the year 2006, we did start the production of the DRAM at AC. And from that time, we start doing many other products like micro SD, USB drive, SSDs, eMMCs, eMCPs, LPDRAM. We also did Wi-Fi Bluetooth modules. In the year 2020, that is exactly last year, we started the mass production of IoT modules. That is exactly the area where I am managing right now. Okay. And this year, we are really focused on the SSD production and the uMCP UFS production as new products. Okay. So you can see here our main areas in Brazil. We have a semiconductor factory that's an assembly and test production line with the capacity of 150 million dies per year. That's located in Atibaia with 5,000 square meter clean room. And we also have SMT assembly lines, both in Atibaia and now in Manaus, that has the capacity of 7 million modules per year. Okay. And we are talking about also the R&D center in Instituto Eldorado Campinas, where finally we finalized our advanced packaging lab, where we can do product development and prototype with 500 square meters. Okay, the capabilities of Smart with all these production sites, we can do system in package. That's something that I will talk today. Integrated circuit packaging process, stacking. We can do stacking of structures and materials. We can do multi-chip packages like MCP, MMC, micro MCP, UFS, LPD run, and also multi-chip for IoT products. That's an area that we are dedicated. We can do also memory module design local, and I have developed the IoT product design group that can do modules, PCB design, evaluation, firmware, systems, RF design. So that's our area in IoT. And at Instituto Eldorado, linked to the IoT products, we are also developing new technologies like laser trench and EMI shielding. Okay. Basically, in IC assembly and test, we can do a lot of things. So wafer backgrind, die up to 30 micrometer thickness, stealth dicing before grinding, SDBG, grinding after laser, flip chip technology. We can do die attach up 16 die stacking capability, multi-chip packaging structures, 11 die package or more. We can do wire and bond, ultra low looping, security, reverse and bump bonding, straight thickness less than 0.10 millimeters. Okay, so we have a lot of technology for assembly and testing ICs here. At Instituto Eldorado, we have a kind of mini smart assembly and test line. So we have a small clean room there. We have a die preparation inline operation, and we have a backend also there. So we can develop new products. We can do research, and we are using this structure now for the IoT. Also, that I will talk later about this. But now we are in full operation, and we can use this for a lot of new ideas that can be developed. Okay. Well, talking about IoT, with all these resources that we have available, you may think that we have plenty of things to do. And basically, for the IoT, we start researching the IoT wireless connectivity technologies to decide which area we can go, and we start thinking about the short range and long range technologies. Of course, for short range, we have Bluetooth, Wi-Fi, Zigbee, 6LoWPAN, Thread, and the recent Matter. It's an area that we could work, and we have been considering studying this area. For cellular, of course, we have plenty of technology for IoT in 2G, 3G, 4G, and 5G technologies. And LP1, it's a new area. And satellite also for IoT is a recent area that we are also doing some research. For LP1, we have several technologies, connectivity technologies, LoRaWAN, Sigfox, LTE, Cat NB, Cat M, YSAN, and the recent MyIoT. Okay, so we decided to focus on the LP1. So currently our work is focused on this area. What means that we have to focus in this base of the pyramid, where we need more coverage, more density, less latency, less mobility, and less data rate. These are the applications that can be addressed with these requirements, like asset management, agriculture, street lighting, water meter. Water metering is a special application because we are really involved in water meter. We have a lot of footprint or position in this area. And these are the technologies that we are working to address this market. This is really our market focus currently with IoT. Okay, we did the first design. As I told you, we had a mass production starting in 2020, and we did a module, a communication module that can work in LoRa and Sigfox and other digital technologies. We decided to start with ASSP components instead of going to ASIP, just to know the market, to know the requirements of the market, the requirements of production, and it's really a really good strategy because we learned a lot this year about this market, about their RF requirements, of system requirements, software requirements, and new ideas. So it was really a very interesting approach that we did. So these are images from our production line. So we test 100% of all modules. So testing is also a challenge in this area. So and we develop all the testing for the production, and this has really rewarding because we have no returns from field, no failures. Okay. We also had to develop other products that can support the operation of the module, like this evaluation board. And here we can also test, for example, the antennas strategies. In this case, we have a chip antenna here. We can also have a antenna. We did also some tests with PCB antennas. So we did a lot of tests with antennas and use this kind of eval boards to do that. We came up with a new idea that we are just launched an article at Embarcado's website. That's the application-oriented AT comments. So our module, with very few comments in a kind of no-code approach, can be transformed in a device. So we don't need any other processor. We just need the battery, the antenna, and some few AT commands, and we have several applications available in the module. This is an innovation, and we are right now exploring this as a differentiation for this module. It's something that there is nothing similar in the world, and it's came up with this experience we had with this module. Okay. We also came up with another idea that we call application module. We enhance or we advanced in the value chain of IoT, and now we have a complete application module. So one side is the connectivity side of the module. You see here we have the connectivity module, the antenna, and in the other side we have all the hardware required for some specific application. In this case, the application is a service call button, an IoT button. So we have here the button, we have a LED, and we have a accelerometer. So, and this board, this is just one board, can be used to implement a device or any other application. Here I'm showing the IoT button that we did as an example. So when we can sell to the customers the complete module with the application and the hardware of the application. It's an interesting idea that we are exploring now, also different from other competitors. Okay, with the same idea, we are working with a tracking application module of the same philosophy. In one side of the board, we have the connectivity, the antenna. In the other side, we have the application hardware. We have the GPS module here, an accelerometer. And in this case, we can implement any tracking application. Oh, it's a very small module. You can see here, it can be inside in a cigar box. Okay. And so we are right now working lots of applications and customers with this idea of the application module. Okay. Well, based on that, so we have enough information to start working on a IC, and this year we start our SIP. We are working with a wafer supplier for all the hardware required in the module, and we are doing the substrate layout development. We already did. We already received the wafers, and at Eldorado Institute, we are putting all this to work. So, and the idea is to go back to our customers and applications and offer the SiP module as an IC developed in Brazil. Okay, and besides all the application we are already addressed, we also want to address new applications where size is important. So during all this journey in the IoT, we found a lot of applications that require small size, and we are not able to do with the current module. And with the SiP, we will be able to do that. And the idea is to create also new versions of the SiP with new connectivity technologies, mixing technologies, and we are now working hard on this. So we are very advanced on this. Soon we will start producing at Eldorado Institute the new ICs, and we expect next year to be in the market with this new technology. Okay, using all the capabilities we have at Smart. Okay. If you want more information about Smart, we just launched our Brazilian site, smartmodular.com.br, and we will have all information about our products design in Brazil, because until now, we have only the American site, and there was no information about the Brazilian products. Now we have a Brazilian website with all the informations, with all products, the memory modules, the memory ICs, the IoT products. You can find all the information there. And also, if you think you have a good idea and would like to know if Smart can work with you in this idea, please contact me, let me know, let's discuss this new idea you have. And also, let's use the Eldorado Lab Advanced Package Lab for new ideas also. And it's not only for Smart, we can discuss other projects using this laboratory. Okay, that's all I have for today. Thanks for your attention.
Okay, thank you very much, Rogério. Very interesting. I didn't know so much about the IoT activities you have. Look like very advanced. Congratulations.
Thank you.
So I don't see much questions, not many questions. I have one question about the SiP. What about the energy? Do you need an outside battery, or how do you integrate the battery to it?
Yes, the idea of the SiP will be a version of our current module in a small package. No? So our product philosophy, we don't touch on the antenna design and the battery or energy or power design. So all the strategies for power and for antenna can be done by the user. So each application requires different strategies. So we have been testing several power strategies, even common batteries or printed batteries. We visit a company in the United States that do printing batteries, so we tested printed batteries. So we are doing several research in order to address several markets. Okay.
Okay, very good. Thank you. Very interesting. So I think we need to go on for the next presentation that will be given by Isaías Silva from Silvaco, Brazil. Challenges and opportunities for global semiconductor business. So Isaías, the floor is yours.
Okay, thank you very much, Professor Jacobus. I'm not sure if you all can see
an Excel
All of
file.
you can see, but it's not what I'd like you to see. So, okay, I think you see the material here.
Yeah.
Can you all see the presentation now?
Yes, yes.
Okay, good. So first of all, good afternoon to everybody. Thanks, Professor Jacobus. Thanks for this opportunity to share a little bit about Silvaco with this audience. So for those of you that doesn't know me, my name is Isaías Silva. I'm currently Silvaco Strategic Director for Brazil. And so Silvaco has around 500 employees worldwide, or a little bit 270 employees, around 500 customers. We are partnering with around 200 universities, and we've been working in a lot of areas. Some of them we touch on base here. I'll talk a little bit later. So our strength is to do what we call from atoms to system. We have the whole spectrum of TCAD modeling, device, processes and device. We also go to analog customers for transistors, and also about systems. We do a lot of design IP, and we also license some IP from all our partners. One thing, I'm going a little bit faster because this presentation was initially scheduled for 30 minutes. So I'll try to cover in, let's say, 15, 20 minutes, according to the timing here. So we are a leading TCAD solution. We have several processes for 2D, 3D. We also are a one-stop shop for analog customized IC designs. And we have a lot of IPs. We have a large IP portfolio for automotive, IoT, memories, artificial intelligence, and we also do a lot of work with services. So we are, Silvaco has been acquiring a lot of companies over the years. More recently, we acquired a company in Brazil called Nangates in 2018. And from this acquisition, we got some people working in Brazil. So we have a R&D center based in Porto Alegre. I'll give you more details later, but this is also, it shows that we are also in Brazil, not only as a sales point, but with an R&D presence in the country. As I said, we have several R&D centers in the world, several sales centers, sales office, and in Brazil we have a hybrid team, sales office in São Paulo area, and our R&D team in the south of Brazil in Porto Alegre. Talk a little bit about the market. We see that the market is growing even with the COVID. We see that a lot of areas that we work are still growing. 5G, PC servers, high performance computing, medical devices, IoT, RF, automotive, medical, power devices. So all these areas are growing, even though we are in the pandemic. Some areas are already moving out. Brazil, I think we are in the middle. I believe next year going to be much less pandemic in Brazil. So that's a good news. We understand that the country is moving on. We also see that major semiconductor foundries are in full capacity. Some people said that already today. And we believe that the pandemic disruption for global supply has created an expansion in the semiconductor infrastructure. So I would say that currently we are probably in the best moment to be innovative, to use innovation, and that's where Silvaco comes into the picture, because we like to work with companies, we like to help the companies to be innovative, to create innovation solutions to the market. Also, we see that the pandemic in the market for COVID is creating new design houses. So this is a very good moment for countries like Brazil, because we can surf, so to say, in this wave and create new businesses in new developments. Also, we see that some markets will be negatively impacted by the COVID, but most of the markets will grow. And I think Brazil will benefit from that. It was said already in some presentations here that the automotive area is one area that is growing a lot and will keep growing. So I believe this is going to be very interesting for our market, and we need to pursue on that. So basically, the first part of my presentation was to send a message that the pandemic created a lot of dynamics that is helping us. The overall productivity increased by 25%. There is a saving the companies. People are learning how to do home office. I confess to you that before the pandemic, I had a lot of problems doing home office. It was not as productive as it is today. So it looks like a lot of people are producing more, and that brings a very good opportunity for us to create new market opportunities here. The other point that I'd like to make is that we believe that the market is growing, especially the automotive, the industrial market for Brazil. It's going to be a good movement. And we see that the Brazilian economy is going up. We see that the GDP is growing quarter to quarter. The GDP prediction for this year, the forecast went from 2.9 to 4.9. I know there was already another forecast, but this is the one that I got when preparing this presentation. And the industry GDP is also growing. The public debt is going down, and exporting in this year, if the core forecast that I got is accurate, we are talking about an increase of 21.5%. So that gives us very good energy to understand that we are in the right place, in the right moment. We've been in Brazil since 2018 with the acquisition of Nangate, like I said, and we have 9 engineers working at Silvaco R&D centers. This team there is doing characterization, and we are working with 2 tools that we have. One is called Cello, that is used for standard cell creation and optimization. In practical terms, the customer can use Cello to speed up the redesign of pre-existing project, involving standard cell libraries, and can create a standard cell libraries or to migrate from a project using in one technology to the other. So this is a very powerful tool. And the good thing about this tool is it has been developed completely in Brazil since the acquisition. So we are proud to say that Cello already speaks Portuguese, but it's very good, and we believe it can help a lot of companies doing cell library optimization. We also have another tool called Viola that was also developed by this team in Brazil. Some of them left the company, but the core is still there working, and then Silvaco hired more people to join these people. And they are doing library characterization, and it's a very good and powerful tool for companies that want to do library characterization. And then another one that does Liberty Analyzer. So, and here is the first phase of Silvaco was to create an R&D center in Brazil. So several companies, when they go to a new market, they start with the sales operation, and then they decide to bring on engineering and R&D. Silvaco was different. We started in Brazil as an R&D activity, and then looking at the opportunities and looking at the potential, Silvaco decided to create a phase 2 to hire people in Brazil to work as a business development and strategic sales. And we understand that in order for Silvaco to succeed in Brazil, the country has to succeed, of course. And we see 3 areas that we need to work together. We need to work together with people from the industry, people from the government, and people from academia. So what I'm going to talk a little bit now is how we see our work going forward with the industry, with government, and the academy. With the industry, Silvaco has elected several areas to push and to work together with some companies in Brazil. We have experience in helping our customers worldwide to do designs for ICs in automotive, memory, precision agriculture, telecom, electronics, medical device, and IoT. So we believe that Silvaco can bring to the table very useful experience, not only licensing the tools, of course, that would be our focus from a commercial standpoint, but also working together with our potential customers so they can achieve a better solution, because we can give them ideas and work together to make sure that the tools fit exactly in their needs. Also, we are offering to the industry several processes, several tools. One is what we call the TCAD, that does process simulation, and the other one that does device simulation. So these are all part of a family of products that we call Victory. So we have Victory Process, Mesh, a Victory Device, and Victory Atomics. These four tools under the same family, they can work together with the customer to model the process and device. And in order to pass the information that our customers model in TCAD Victory to the next phase for the SPICE model, we have one tool called Altumos 4 together with other tools that can help to do the modeling and simulation. Sorry, okay. When we go to the EDA design flow, we have two sets of tools. One set of tools is called the design capture and layout, namely Gateway, Expert, Smart VRC, Hypex, and SciPix. And then we have the simulation analysis. And for this area, we have SmartSpice and a whole bunch of tools here. So the idea is to make sure that our customers, they have everything they need in order to design a solution to the market. And then we have the tools that I already mentioned that we developed in Brazil. One area that we believe can also be of interest for some companies and institutions on this audience is the IP licensing area, where we have several IPs designed internally or licensed from third parties, so we can help the companies to shorten the time to create a new product. So instead of developing a tool from scratch, they can benefit from having an IP in terms of time to market. And then we have the government. We understand that Silvaco's main, let's say, positioning with the market is to help the government, whatever need, to give information and to give anything that we can leverage from our experience working in Asia, working in Europe, in US, that we can somehow help the government to create and to improve the local programs that are already there. So the government can create processes and ideas that can benefit the local industry. So I put here some of the programs that we are discussing with the government. And so Silvaco is here to help. Silvaco people has a lot of experience. I myself and my team in Brazil and US and other areas. And we are here to do as much as possible to make sure that the Brazil does the right thing in order to progress in the semiconductor industry. And then talk about the academy. We are in contact with several institutions in Brazil. We are creating some programs and participating in some actions to make sure that the Brazilian academy has the necessary ingredients to create good IC designers that can be either hired by Silvaco itself and grow our presence in Brazil, or be hired by other companies and keep using good tools as our tools. So this is our commitment to the Brazilian market. And we have what I call the pentagon of partnerships. There are 5 areas that we are working in Brazil. I'm not going to give you too much detail, but if somebody from the audience wants to talk to me, I'll leave my email address in the chat so you can reach me and discuss more details. So first of all, we already have a Silvaco R&D center activities in Brazil. Would like to grow those activities here together with other companies or universities. So this is part of our commitment. We understand that the only way we can succeed is if we help the country to succeed. So that's why we are very serious about having presence in Brazil. The other one is EDA tools and IP licensing programs that we have, not only with good pricing and conditions, but also in partnership. Sometimes we have a customer that is developing something, and in the process, they can help us a lot to improve our tools. So we are open not only to sell, but also to hire companies to help us to improve our tools. We have an academic licensing program that is also being placed in Brazil, helping some universities to grow and to use some of our tools. We have a program, a kind of a SIP for industry development, when we have a company that is interested in developing a solution to the market, we can team up with one of local design house to develop the solution, and an EDA residence program where we can help some company to train engineers to go and to work with our tools in their company. We also, what do we expect from our partnerships in Brazil? First of all, is to help to strengthen the value chain. So as we interact with the academic and R&D centers, design house, the electronics industry company, and the market sectors, we understand that the market will go more and more, and we can benefit from that. The other area is to add values to universities and R&D centers and IC design framework. So again, as you remember from my presentation, Silvaco has 270 employees, and we have partners of 200 plus universities. So it's almost one university per employee. So we really would like to be a partner for the local universities, not only to license, but also to work with them in some R&D project that can be mutually beneficial. Another point is to see IC design opportunities from various market sectors. This is also part of our mission in Brazil, is to help startup companies. Sometimes you have a startup company that is willing to grow, but they lack information or training or something else, and we can help them here. And finally, to help Brazilian ecosystem to create high-level, high-class HR experiencing engineers that can either be hired by Silvaco, of course, or can be in the market making a difference. So I believe I was successful in finishing my presentation in less than 20 minutes. My main message is that we are here to stay and to cooperate. And in the September 28th, we're going to have an event called Silvaco Day in Brazil. If you are interested, I will leave also the link here, and you can subscribe and participate, and we'll be more than happy to share more details about our company. Thank you very much.
Okay, thank you very much, Isaias. Very nice. I think we have a lot of synergy with Silvaco for the universities, for the companies, and government will also benefit from this. So I think it's great seeing your presentation. Because of lack of time, I think we go directly to the next. the last presentation given by Jacqueline Reis from IDEA Electronic Systems about ASIC design for ultra-low power consumption coherent optical DSPs. So IDEA is one of the design houses we have here in Brazil, and this one especially in my city called Campinas. So I welcome Jacqueline to give his talk.
Okay, thanks a lot, Professor Jacobus, for the introduction and also for the invitation to IDEA to be here and to share a little bit of our work. I'd like also to thank my colleagues at IDEA. Everyone in our team has contributed for this work, and it's a pleasure to be here representing their hard work with all of you. And good evening, everyone. So I'll try to keep in the time that we have for this discussion today. So as Professor Jacobus said, we will discuss a little bit about ultra-low power consumption designs for coherent optical DSP ASICs. That's one of the works that we are doing at IDEA. So IDEA, just to share a little bit more about us, since last year we became a group where we have 3 companies in our group. IDEA, which is mainly focused on research and development in microelectronics, photonics, and product engineering. PyTech, which is a systems and modules manufacturing, and also BR Photonics, which is a photonics device manufacturing. So all of those companies, they share the same ecosystems of resources and all the technology evolutions that we have been involved in the past year. IDEA, as I will talk a little bit more about today, focus on R&D development. And in this talk, although we are a group split into 3 companies, I will focus essentially in the work that we are carrying out in the microelectronics department inside our R&D group. So for those of you that doesn't know IDEA, we are located in Campinas. We have 2 engineering headquarters. We have a very big ecosystem that we have been working very closely with all partners, including universities, R&D centers, and also companies. Some of them they are here today with us in this conference. We also have a very close collaboration with Eldorado and CPQD, where we share some of the infrastructure, especially to do our photonic development. We also have a very close relationship with Unicamp, University Federal of Campina Grande, and many others that work in different areas at IDEA Group. Our team has increased quite a lot in the past years. This year we will reach around 150 employees, split in the 3 different companies that I mentioned in the beginning. We also have more than 90 people involved with us among our ecosystem or through our ecosystem. And it's very interesting and exciting to have all of those people working in very challenging problems that we are dealing today. So in the R&D, let's say, department inside IDEA, we cover many applications, including telecommunications, medical science, and industry. But in this talk today, I will try to focus mainly on telecommunications, covering different applications areas such as metropolitan networks, long-haul networks, submarine, data center interconnects, and low-orbit satellite communication. So in the past few years, the optical communication industry has been going through a very interesting path where many of the big equipments that were used in the past, they are still being used today. by telecommunication operators to deliver internet connectivity or internet services to end users. They are evolving from those big racks of many WDM channels with many optical fiber interconnects to what we are calling small form factor pluggable coherent transceivers. So it's been quite interesting to see this revolution in this industry, because many of the technologies have been vertically integrated into these very small compact form factors. And this is where exactly we try to focus our efforts in the past few years. So IDEA has been working very close with our US partner in order to develop these components, those products that basically integrate all the core IP technologies. And I will talk a little bit more about them, but it's very interesting to see that this market is growing quite a lot, especially with the adoption of data center providers that has been invested. I would say the majority of or it's driving the majority of the investments in this kind of infrastructure. So here we can see a little bit of what is how this form factor looks like. So it's basically it's a mechanics with all components, the optical electronic components inside of it. We have the lasers, that's essentially the light source. We have the silicon photonics, which is responsible for the optoelectronic conversion. We have optical amplifiers to be able to regenerate or to boost the optical power that we launch into the optical fiber. And we have this device here, which we call DSP ASIC, which is essentially a natural electronic device, an ASIC that is responsible for all the signal processing, and that we will discuss a little bit more about it. So our solution today focuses on data center interconnects, where essentially those companies such as Microsoft, Facebook, Apple, and so on, they build these huge data centers, which has many of Ethernet equipment inside of it. And because of the throughput that those data center requires, we have to use these very high speed transceivers. So we are talking about speeds of 100 gigabit per second, 400 gigabit per second, and next generation transceivers will be working at 800 gig and beyond. And in these form factors, we have all the core IPs, as I mentioned before, the DSP ASIC, the silicon photonics for optoelectronic conversion, the laser, which is our light source, and also optical amplifiers inside of it. So in these coherent optical DSP ASIC, because of the very tight constraints that we have of low cost, high throughput, and also very low power consumption, we have to use what is the best available in the industry in terms of process fabrication and also design knowledge. And that's where I'll try to focus today in this talk. So our flow, essentially, we cover the entire microelectronic flow to design an ASIC. And we have many people working in different pieces of this flow. But essentially, we start from the spec all the way to the final design to the foundry. So we follow the fabless concept, but we are very vertically integrated in order to control all the different phases of the design to extract the maximum performance in terms of energy consumption. So we start with the spec and modeling to try to understand our requirements with our customer. We go through what we call the logic design, that's essentially focus on the architecture of the IPs that we are developing. So we cover both the signal processing that handles all the fiber effects that we have during optical fiber transmission, but also the network protocol that is used in this type of network. So all the Ethernet protocol and also the OTN, the optical network protocol, the physical layer aspect of those protocols, we start designing as well together with our partners at IDEA. So after we build this architecture, we move to the physical design that is very tight, connected with the foundry and the fabrication process that we will use. What we have learned in the past is that those two, let's say, phases of the work, the phases of the flow has to be very tightly connected. So all the design that we do at RTL level has to take into account the process fabrication, and also all the physical design that we do using FinFET node technology has to be very tightly connected with this RTL design. And of course, none of that make any sense if we don't have a very advanced verification methodology, because that's what will tie all this functionality together and, let's say, deliver the performance and the requirements that we are trying to cover for different designers. And of course, this is let's say, the path that we have in the design aspect in our flow, but we also have all the integration work that's dealing with the integration of different digital IPs as well as analog IPs to have, let's say, a complete physical view of the ASICs that we are designing. We are developing as well design for testing to be able to test for very high volume for these IPs. We work very close to our partners to also have access to the best-in-class analog IP that we require for this type of ASICs that we have. And after we deliver this design for the foundry, we have to go to a new round of, let's say, work that essentially focus on to validate at the lab all the functionalities that, let's say, we agreed with our customer. And today at IDEA, we cover this entire flow from the spec all the way to the silicon validation in the lab for the ASICs that we are working on. So one of the main challenges that we are facing today, and not only us in this industry of optical communication, many industry are looking into that. It's related with the power optimization flow or the power consumption that you have to achieve. As I mentioned in the beginning in this talk, optical coherent transceiver has changed quite a lot because of these new requirements that hyperscaler data center providers has presented to the entire industry. So they are pushing very hard in the standardization body solutions that are interoperable, but at the same time very optimized in order to be able to fit in a very compact module, to be able to fit as many ports as we can in a switch Ethernet equipment. So at IDEA, one of the things that we learned doing this kind of design is essentially that you have to work very close to your customer to really understand what are the requirements and their specs, and to see what you can trade in terms of performance for power consumption. And this is not sometimes a easy job, because everyone in the end will specify the lowest possible power consumption. But there is no free lunch, right? You have to take some very tight requirements in order to really be able to meet those requirements. So just to share a little bit more with you, in the past, 100G transceivers consumed more than 100 watts. Like we are talking about 5 or maybe 6 years ago. And the same 100G, 100 watt has decreased to, let's say, 15 watt consumption, but 4 times faster than before. So we are talking about transceivers working at 400 gigabits per second, and the power consumption has dropped from 100 to 15 watts. So that's quite challenging to meet, and that's why you have to use the best fabrication process that you can. So the other thing is in terms of functionality and algorithm, as I mentioned to you, this kind of device that we design at IDEA essentially perform lots of numerical calculations to compensate all the fiber effects propagation that we have, to perform network protocol, to perform forward error correction, and all of those mathematical operations has to be optimized. And of course, the major benefits come from this phase of the work. But that doesn't, this essentially will not be the final solution if you are not able to really estimate what you are doing, what you are achieving in terms of power consumption during the phase, during the design phase. And that's why we highlighted here that is very important for you as well, in order to have a very power optimized solution, to have a very accurate power estimation methodology that comprises extraction with simulations at gate level, because that's in the end what really will drive your design. After you, let's say, build this kind of flow, then you, let's say, have the baseline for you to be able to really design all the digital circuits that you have, but pretty much aware of the physical implementation. So you have to work with your customer and the foundry in order to have the right PVT, the right process, voltage operation, temperature operation, because that will change quite a lot your design, to have everyone contributing with the forward planning of the ASIC, and try to have the RTL design exercising as much as possible as well what we are calling trial, place, and route, in order to really have the physical, let's say, design feedback so that you can improve your design. At the same time, the physical implementation has to be aware of your circuit design functionality. So it has to work with the RTL engineers in order to really set the right constraints, to understand the critical path, and to develop the design methodology that is aware of the design functionality. So we are not saying that what we understood is that the physical design has to be aware of that as well. And in the end, everyone has to contribute for this problem. It's a very difficult challenge to overcome. And we have to look in the 3 main, let's say, dimensions for this problem, with the front end team working very close with the verification team as well as the backend team in order to extract the maximum efficiency in terms of energy consumption. So this is just a little bit of history of what we have designed so far at IDEA. So our first generation ASIC that we taped out in December 2017 covered 100G solution. We used 28 nanometer CMOS process. It was an ASIC with more than 100 million transistors. And it covers basically these WDM optical communication systems from 80 kilometer all the way to 2000 kilometer. Then we moved to 7 nanometer process because of the power consumption constraints that we had. In this process, we were able to do 2 test chips, one back in 2018, in September 2018, to validate our 7 nanometer flow and to exercise some of the IPs that we were designing. Then we had another test chip taped out in February 2019 using the same process, but focus on a different IP, where we're able to cover all the SerDes technology for a very short reach, common electrical interfaces running at 112 gigabits per second. And the full 400G solution, we completed the design in this preview process in 7 nanometer in January 2020. So it was a big design with more than 250 million transistors. Our 3rd generation, we just completed last month, where we designed together with our partners, 6 nanometer ASIC for 400G solution as well, with more than 400 million transistors in this solution. And we are working in our 4th generation design using the same process, but with what we're calling a flexible solution that can work in different bit rates from 100G, 200G, 300G, all the way to 400G solution. So this is essentially what we are doing at IDEA in the microelectronics department. And I thank you very much for your attention.
Okay, Jacqueline, thanks a lot for this interesting activities you are performing. Very impressive, doing such advanced nodes and so many transistors. Very complex chip, very interesting and challenging, I believe. Good to see that design houses are doing such nice work here in Brazil. We have another work panel on Friday afternoon, where also IDEA will be present, and other design houses. There we will see more design houses in Brazil, also the new ones. So that's also very important. And I would like to invite everybody to come to this panel discussion on Friday afternoon. But we can open for a few questions still if the speakers are there. I see some of you are here. So any question for Jacqueline and for others? So I see that Sergio asked for Isaias, if he can explain more how the ADA software residence program will work. That is in Brazil. He means in Brazil, not in the US. So
yes,
open table here.
Okay, I already answered Sergio on the private, but just to give you a glimpse, but basically we have some companies that we're discussing that would like to develop one particular solution, but not only develop, but to develop its own people in some particular tools. So sometimes we not only license the tools, but we train their people, and that can be Silvaco, the company, or we can involve a third-party university or R&D center that is already using our tools to be the institution that we train the third-party company information. And we call this a residence program because the people that will be trained will be pretty much working together with us and in the university or R&D center to be trained for the company.
Okay, thank you. I have a more general question. I think I address it to Wim about the landscape for semiconductors after the debate between China and the US. We saw in the first semester of the year that US and also Europe, they are trying to attract foundries and also related with the lack of supply of semiconductors. So can you elaborate something, your view about this?
Sure, I can try to elaborate a little bit. Thank you for the question, Jacobus. I think it's still a fact that for people outside the semiconductor industry, it's difficult to understand how globalized it is. You cannot just localize it and think you can have the entire value chain in your country or in your city. And whenever you see semiconductors receiving world scale attention by everybody in and outside industry. It's always the same that people from without or with less experience in the industry maybe judge it in a different way. But from our point of view, the investment and trade point of view, our agency attracts foreign investors to Belgium, of course, and we help to promote our own small and medium enterprise abroad in most of the countries around the world. We've seen a lot of traction from semiconductor companies in both directions. So our young and fast-growing companies are increasingly looking abroad, although they cannot travel. Sometimes they look abroad, they expand abroad, they hire remotely abroad more than ever. And also from the foreign investment side, both from every continent that has a semiconductor industry, we see more and more traction. And that's also one of the reasons we are so happy to be part of this conference today.
Yeah, okay, thank you. I also see that I'm somehow optimistic about Brazil, although the difficulties will live here. But for instance, this conference, we have 350 people. So that's, and in a difficult time. So very interesting that the number of people in the area seems to be growing. And also we see more and more design houses. So there are some positive, although we have many difficulties, and for instance, we have bad examples of foundries here, like Zeitec and Unitec, but the packaging is doing well. So I am rather optimistic about future. We have opportunities here in Brazil. I think I don't see any more questions. That is good for the time being, because we are maybe half an hour overtime, and it was a long day. I think the conference is, I'm happy with the conference, how it is going on. And with that, I think we can finish here our session and our day, and we resume tomorrow with a full program in the next days. And you are all invited for the other sections, panel discussions, and there's a very interesting program. So we thank you, and especially because you are all sponsors for the conference, which is very important for us, that we have your support. We are very thankful to all these sponsors for the conference. So with that, I think also if you can share your presentations to me, I will. We will put it in access for the people that are participating to this session. So with that, we thank you all and see you later this week.
Thank
Goodbye.
you.
Thank you.
Bye-bye, everyone.
Thank you. Thank you, everybody. It was a pleasure.
Thank you for organizing.
Yeah, it was our pleasure. Thank you.
Thank you, Professor Jacobus. Thank you, everyone.
Yeah. Goodbye.
You are explorers. It's who you are.